Okay, finally got this thing working. Alright, I promised you guys that I would work out one or two of the challenge problems. I'm going to take a look at this one where your starting height and your ending height are not the same thing. First time through, I'm going to look at it from the positive physics standpoint where they're using distance is average speed times time, final speed is equal to initial speed plus or minus acceleration times time. Please remember the way they've been doing it. If the acceleration is making it speed up, then it's plus acceleration times time, and if it's making it slow down, then it's minus acceleration times time. Same deal happens for the other equation they have. The distance is equal to the initial speed multiplied by time. Usually this is 0 for problems in which you use this one, plus or minus 1/2 the acceleration rate times time squared. You add distance if the acceleration is making it speed up, and you subtract this second term if the acceleration is making it slow down. Okay, in this problem, student fires a cannonball vertically upwards with a speed of 23 meters per second from a height of 55 meters. On the descent, the cannonball misses the building and lands on the ground. Determine all of the unknowns and answer the following question. Neglect drag and horizontal motion of the ball. Okay, we need to do this. If we're going to do this positive physics way, we got to do the way up and then separately the way down. So for at least for part 1, this is my final position and this is my initial position. They want to know what the maximum height is measured from the ground. All right, and they did tell us that this height here is 55 meters. And they told us that the initial speed is equal to 23 meters per second upward. That means we can only use this in the upward direction part of the problem. We do know that it is falling through the air, so the acceleration rate is equal to 10 meters per second squared, the value of g. And we know that on this upward path, up here at the top, it has a final velocity that's equal to 0. Here's our 3 unknowns. Now we can find just about anything. We're going to figure out what the height is here. So for part 1, all right, so I'm going to say F1 and initial 1, and I'm going to call this distance 1. What they want here, the total height from the ground, is going to be distance 1 plus the 55 meters. All right, we have an initial speed of 23 meters per second. We have a final speed of 0. Therefore, we can figure out the average speed. The average speed is going to be equal to the initial speed plus the final speed divided by 2. The initial speed was 23 meters per second, and the final speed is 0. Divide 23 by 2, and we get 11.5 meters per second for the average speed. With the average speed in place, we can look at the distance. Distance is average speed multiplied by time. So 11.5 meters per second multiplied by, oh, wait a minute, we don't have the time. So that's going, we're barking up the wrong tree here. Not going to use that one. We can use, well, actually, all of these have a time variable in them. I forgot, there is one equation that I didn't write down, and that is a special version of this. When one of the values, either the initial or final, is equal to 0, then the distance can be equal, I'm sorry, not the distance, the time is equal to the square root of 2 times the distance divided by the rate of acceleration. Alright, so that's the thing that we need to get us our time. Then I guess we didn't have to scribble that out. The time to go up to the top is going to be, we're working in circles, aren't we? Okay, so what do we not need? We have final, we have initial, we have the rate of acceleration. Oh, right there. I'm going around in circles. Okay. So, that expression, since we are slowing down, final speed is equal to the initial speed minus the acceleration rate multiplied by time. Therefore, to solve this for time, I have final speed minus initial speed divided by negative a. Final speed is 0. Initial speed was 23 meters per second. The acceleration is 10 meters per second squared. Remember, the way they're doing it, the plus or minuses takes the place of the positive or negative values for the acceleration. So we end up taking 2.3 seconds to get up to the top part. So again, going from here down, the distance is equal to the average speed, which was 11.5 meters per second, multiplied by the time in the air on the way up. I might even put a 1 on that time. So this was distance 1, and that's 11.5 times 2.3, so 26.45 meters. That's distance 1. The height that they asked for, h, let's say h is the total height for part 1, how high above the ground. That's equal to the height of the cliff or box or whatever it is, building, plus d1. So that's 55 plus this guy here, 55 plus 26.45. Actually, I should write it down. 55 meters plus 26.45 meters is equal to 81.45 meters. That is our first answer. 81 point, the number's big enough to chop it down a little bit. 81.5, and that's going to be meters. With what speed did the cannonball strike the ground? Well, that means we're going to have to now switch to the second part of the problem. So for the second part of the problem, this is my second initial position. This is my second final position. For situation 2, my initial speed, I'm going to switch colors here. S initial for situation 2 is equal to 0. The acceleration is still equal to 10 meters per second squared. The distance traveled, we just figured that out a second ago, is 81.45 meters. Oh, that's distance 2. Acceleration is the same in 1 and 2, so I'm not going to put a subscript on that. Here's our 3 variables. Now we can find the other stuff. They want to know final speed. So final speed is equal to initial speed plus or minus. It's going to be plus because it's speeding up. Acceleration multiplied by time. Again, we do not have the time, so we're first going to use the equation they have for time in terms of distances and accelerations. So the time is equal to 2 times the distance divided by the acceleration rate. So that's 2 times 81.45 meters divided by 10 meters per second squared. If we look at our units, we're going to end up with meters squared over seconds squared. I'm sorry, no we're not. Meters divided by meters per second squared, so meters are going to cancel out. We're going to end up in seconds squared, which then gets square rooted, so seconds. So 2 times 81.45 times 10 equals then square root 40.36. 40.36. That sounds like an awful lot. I want to double check that. 2 times 81.45 meters is 162.9. Divide that by 10 and we got 16. Yeah, I knew it. I must have squared it. 4.036. It wasn't that high in the air. 4.036, and that is going to be seconds. So now I can come back to this one here. So my initial speed was 0. My acceleration was 10 meters per second squared. Multiplying that by my time of 4.036 seconds is just going to move the decimal place around. And so that's going to be 40.36. I'm going to say 40.4. And that is going to be meters per second, because this second cancels out the squared on those seconds. So meters per second, that is the speed at which it plows into the ground. So that's our second answer, 40.4 meters per second. What was the cannonball's total flight time? Well, we've already found the time twice, so the total time is equal to time 1 plus time 2. So that is simply 2.3 seconds on the way up plus 4.04 seconds on the way down. So 6.34 seconds for the total value. 6.34 seconds. Alrighty, I'm going to post this, then I'm going to come back and do this from UAM equations and see if we can do it more short, a little bit shorter than that.